Okay, let me show you quickly how you can use Excel to calculate betas. It's really, it's so much simpler.
George, I have a quick question for you. So then does that mean beta can't be negative?
Beta can be negative because, remember, it's the standard deviation of the stock over the market times the correlation coefficient. The correlation coefficient can be negative.
So then in that formula, that risk-free times whatever formula, if you're multiplying like beta and beta is negative, then wouldn't you get like a negative number there?
Yes, and that's why I made the caveat that negative beta stocks generally don't exist.
Oh,
Two assets that are negatively correlated, they're almost non-existent.
okay.
And if you remember the list of the expected returns, the correlations between the stock market and small caps and treasury bonds, the slide I showed, they're all positive.
Okay.
Okay, so the model is really a lot, Excel is much friendlier than it used to be when we had, in fact, had to use a regression-based model. Now there's a nice simple little function. This is just calculating expected and required rates of return. I want to make a point, one specific point here. You'll notice that the occurrences, that the probabilities are on the screen here. This is not very big. Let me blow it up. The probabilities, you might be tempted to use the STDEV function in Excel, standard deviation function, to calculate standard deviation. And you can do it if those probabilities are all the same. Excel assumes standard deviation. There's no way to specify probabilities in the STDEV formula in Excel. So typically you have to calculate it by hand, which is probability times expected return squared, and so on. So if the probabilities are all the same, you can use the STDEV function, but if they're not, you have to do it by hand. Rate of return. And again, this just shows you how you can calculate, again, these deviations. Is simply, you can see it's taking the probability times the square root, times the square of the difference between the two. Again, I'll let you go through now. I want to get to the beta because this is where it's really nice to, there's a very nice function to be used. Calculation of beta. So here we've got our stocks, the L, M, and H, and there's the market at 10-20%. So you can, in fact, use the slope function in Excel. And all we're doing there is we're simply regressing stock L against a C 69 to 71 against B 69 to 71. And that tells you the slope is 0.5. That is the beta. So it's really simple to use, and it's very handy to use when you're making a financial risk calculation. And then similarly with stock M, we're simply regressing D 89 69 to 71 against B 69 to 71. And often you have to make sure that the first row or column that you highlight is the stock, and the second one is the market. Or the first one is the investment project, and the second one is the rates of return on the organization. Because it's Y against X. And then you can graph the regression lines using that data that I just calculated. And then finally, the capital asset pricing model here is used, which just shows you the arithmetic that can be used. There's a nice little model there as well. So it's a pretty good model. And then the security market line, which I showed you a few minutes ago. Again, these are different rates of required rates of return against different levels of data. Any questions about this so far? Now let's try the in-class problem. Let's see. Take a crack at this. Yeah, I just showed you how to use the slope function in Excel. That's what you're going to use here. Required rate of return to market 11%, risk-free rate 6%. What's the required rate of return on the first held stock? We're going to use the capital asset pricing model.
The mini case or is this?
No, this is just an in-class problem.
Oh, it's not on the Sakai.
Not on Sakai. You've never seen this before. All the in-class problems I give you like this, you will not see them. In many cases, you do see them. Okay, someone want to shout out an answer? That's not the right one.
Yeah. 1 second.
One point 24%. 1.34%.
8.27.
Okay, how did you get that? I'll put the answer up.
That's what I got too.
You calculate the beta by doing the slope formula of the market or the stock compared to the market, and you multiply that by the market risk premium, which is 11% minus 6%, and then add that back to the risk-free percent. Probably not the clearest explanation.
Good enough. So what he did was he used the slope function. The beta is 0.4534, which tells you what about the risk of the stock? compared to the market.
It has half the a little bit less than half the volatility of the market.
It's half as volatile, half as risky as the market. In fact, you can see that just by eyeballing it. The range of the market from the highest to the lowest isn't as great. So once we calculate the slope, which is the point of beta, we then do this calculation here, which is the risk-free rate at 6%, plus the difference between the 11 and 6%, times the beta, and that gives us 8.27%. So the required rate of return, the rate of return that investors would demand on this stock, would be 8.27%. They would then compare that to the expected rate of return on the stock, and if it's greater than 8.27, they would buy it, and if it's less than the 8.27, they would not buy it. Any other questions about the concepts of what we've been talking about? Does everyone follow this arithmetic and what we did?